Alrighty, old gatekeeper here. We got a midnight special 700 Xforce midnight special. One driving four, all DEI 1446s, and first thing I noticed when I got the amp, which I have just left alone at this point because I don't know if it was like this before you sent it, or I don't know if this was done during shipping. But if you'll notice, you got some got one of the fins on the heatsink bent pretty bad. You can tell it was dropped on that exact side right there pretty badly. So I'm actually going to wait and let you tell me if you want me to attempt to bend that back. It's bent pretty bad, or if you want to bend that back yourself. I should be able to bend it back, no problem. But I just wanted to show it in the video first. Sometimes you'll bend back them fins and they won't look exactly the way they did before it was bent. So basically, first thing I noticed with the box is it wasn't making any watts whatsoever. Okay. I fixed the issue why it wasn't making watts. I don't know why, but there was an actual cold solder joint on the RF wire of the driver section on the input transformer. Okay. Once I fixed that, it just wasn't making the amount of watts that it did 1446s should be making. This kind of alarmed me at first of, you know, why you'd need that much resistance as a padding resistor coming from the variable over to the driver section. That's something right there that you would normally do on a 2x4 or possibly a 1 driving 2, which basically helps back down the driver section a little bit. It takes a little bit of your power that you're putting into it and backs it down. And I was like, I don't really know why you'd need this much with this type of configuration. Me personally, I would go with a full 1446 straight, you know, without using a 1446 driver. But this would be good for a real small radio. You know, pretty small radio, single funnel, small radio. So anyway, what I went ahead and did at first was I removed this two 100 ohms, which equals 50 ohms in parallel. I took that off and dropped a 10 ohm resistor in. Now, this is what was kind of wild. Before I did that, it didn't have really no input reflect. I wasn't showing much input reflect at all. Okay, as soon as I removed that and put the 10 ohm there, booyah, had 1 watt worth of input reflect. So what this was doing was basically hiding that input reflect, because if you think about it, what causes input reflect? Okay, just like with your antenna causing SWR, an impedance mismatch. This is a whole impedance game, which is I like to call an impedance game, because you're always playing the impedance game when you're dealing with these amplifiers. It's a game. Usually I win. I try my best to win. So, as you see, we have I ain't gonna get into school or nothing, but you have a transformer here. And what you're attempting to do is take that 50 ohms and bump it down to a smaller amount of ohms, just to put it in layman's terms, because this transistor does not take a 50 ohm signal. So you have to drop that 50 ohm signal to the exact impedance that this transistor will accept, or you will not have full load of RF going into the transistor. Now, if you do not get the transformation as close to 50 ohms as possible, you're going to have an impedance mismatch. And like, let's say, for example, you're putting a 1 watt dead key into this amplifier, or a 2 watt dead key. Let's go with a 2 watt dead key into this amplifier, okay? That means that a portion of that 2 watt dead key is going to be going back this direction, meaning it's going to be going back from here, right here at the feed point of the transformer, through the variable, back down the coax this way, through the relay, back this way, to my bird meter, then out. See, that's why we're reading the wattage. So what this was doing, the 50 ohms, was taking that reflect and soaking it up in the resistor. And you ask yourself, yeah, that's good for safety purposes, but we want the full amount of power being dumped into this transistor. Because if you get a full transformation of power, then you're going to have more output, because more power is going to be going into the amplifier, and it's going to stay cooler. Any kind of reflect is going to cause heat. So when I took that off, and that's, some people are bad about that. They'll throw an attenuator on an amplifier and they'll tune it with the attenuator on it. The right way of doing it is tuning the amplifier without the attenuator on it, then putting the attenuator on it. So we had an issue. I noticed we had an impedance mismatch. I tried to make it work with a wrap configuration that was on here. This wire was on the input transformer with 2 wraps. I myself have never used that configuration with a 1446 box. I've always went with a 5 on the input, 2 on the output of a 1 transistor driver section. But I went ahead and attempted to go with it. When I put my trimmer in here and tuned the box out, it took 365 picofarad worth of capacitance to lay the input down. And it still wasn't flat or anything, but it was very acceptable. But I knew that was a red alarm right there, because there's no need for you to need that much capacitance. So at that point, that showed me that that was not the proper wrap configuration for this particular setup. I'm not saying it's wrong for this circuit or anything, but for what we got right here in front of me, it was not working well. So the first thing that I did is I removed the choke on the input transformer. That actually brought your dead key down. So that's why they were also having to add this right here, because putting 1 watt of dead key in this thing was producing a 200 watt dead key. Once I did that right there, just taking the choke off, it dropped down to about an 80 watt dead key, and it swung more power. So I only put the, I won't get into all that. I only got like 2 more minutes on here. But anyway, so I rewrapped the input transformer, retuned it, and it laid down flat, very flat. I rerouted the power wire too to the back of the transformer right here. It was laying down right here in front, which is fine. I just wanted to do that just to be safe. And this box is working well now, bud. We got this thing rocking and rolling for you. A little bit of labor, but not too much. I was getting a little frustrated trying to get it tuned in with the 2 wraps. I did spend a little bit of time with that, but went with what I know, laid down flat, and it's working well. All right, so we got the 4 watt radio on it. 1000 watt slug. Okay, this is RMS first. Oh, 200 watts RMS. We were only getting about 100 before. Oh, let's let you look at the dead key. Right there, about 80 watts, like I said. Oh, then you can take that variable if you want to turn that dead key down a little bit more. All right, here's your input reflect. Oh, look at that, beautiful. Oh, oh. Alrighty. It was sitting right there about 1, right there, a little bit over 1 watt. All right, here's your PEP. This is just with a 4 watt radio. Oh, what's this thing talking though? About 580 watts. Break. That is on 15.2 volts, I believe. Oh, yep, 15.2. Alright, let me press pause. There's really no need to do this, but I'm going to hook up a hot radio real quick. There's really no need to put that supply on the 100 amp tap. The voltage will be too high. I'm just going to leave it to where it's at. Although this will put a bit of more of a load on the supply over there. But we're just going to hit it with the hot radio. I personally, I know you ain't seeing the big 700 watts that's advertised, but these are also DEIs. They're not ST1446, because I guarantee you, if there was STs in here, you'd probably see 100 more watts PEP, but we're looking at the bird. 200 bird, 4 watts RMS going in. That's a good ratio. That's a good ratio. Alright, be right back. Alright, we're now driving 8 watts RMS into it. Oh, right there, almost 300 watts. Oh, 380. And it's dropping to 14.2. So there you go, bud. Got her fixed, got her back up and rolling for you. You need something like